Variability. I just finished changing slide 18 from 9-4. I'm sure you're all relieved to know that. All right, so order the test scores from least to greatest. Hopefully we can still do that, and when we do, we get that. Now looking at these, the test scores, the median. Median is the number that's in the middle. There's 2, 4, 6, 7. So that means the middle number, the one with 3 on each side, is 89. Find the difference. Subtraction. Don't forget, line up decimals. That's key. Problem of the day. Again, good job, Isaac. Learn to find the measure of variability. We've made these, or made this one. These will help us with things. We're going to learn them for a second time, our second year in a row. Y'all can read. Pause and read it if you need to. I'll hit the high points. Variability describes how spread out the data numbers are. A box and whisker plot uses a number line to show how data are distributed. The first quartile is the median, or the middle of the lower half. The third quartile is the median, or the middle of the upper half. So think about it like this. I find the median. Now with the median, I got two halves. The first quartile and the second quartile. Now, the first quartile is the median of the lower half. So there's the lower half. Oh, first quartile would be the middle of that. The median of the upper half would be the second quartile. So the middle of there. The only difference is, instead of doing it with a rectangle, we will do it with numbers. So, we look here. We have our numbers. This is our smallest number. This is our greatest number. 2, we have a 3, a 4, a 5, and a 6. So 2 and 6, when we have 2, 3, 4, 5, 6, 4 is the middle. It's the median. So now, when we have that done, we have our first half. Our first half is 2, 3, 4. Well, the middle, or the first quartile, is 3. When we look at the second half, 4, 5, 6, the middle of our second half is 5. Now, what they do here for a box and whisker, they connect these and make a block. That's where people are most likely to be, remembering the median. All right? People are most likely to be in this middle range and less likely to be on the outer edges. But notice they put a line here to show and cover the whole range. Getting the first quartile and the second quartile is a great way to see where your test scores are falling. All right? So we had from a 2 on the test to a 6 on the test. All right? We had a 3, a 4, and a 5 on the test. Most people were in this middle range. There was an outlier of 2, an outlier of 6. I think it'll make a little more sense once we jump in. So, order these numbers. That's the first thing we got to do. When we order the numbers, now, there's 2, 4, 6, 8 numbers. Now, being that there's 8 numbers, we find the middle 2. The middle 2 are 19. 19 is our median, okay? Then, we want to look at our first half. 16 is going to be our first quartile. We want to look at our second half. 21 is going to be our second quartile. We've got that figured out. Let's see how we put that on one. All right, least value, our greatest value is that. Least value is this. Okay. So, first quartile when we divide them in half is that. Second quartile when we divide them in half or divide them there, is 21. The median is 19. They put the same box as I did. Let me erase mine so you can see their pretty work. Okay? I think it's easier to find the median first so you know what your two halves are. They chose to say here are the two halves, and we went from there. When we put this on a number line, here's what we need to do. Okay, 13 was your least value, 25 was your greatest value. Median was 19. First quartile was 16. Second quartile, that median of the second half, was 21. So now we've got those. Knowing what each one is important. So, draw the box and whiskers. Here's your whiskers. Here's your box. First quartile to second quartile, we make a rectangle, making sure we know the median. The median's a little higher in that interquartile range. The space between the quartiles is called the interquartile range. That'll come up. All right? So this interquartile range between 15 and 21 is the most likelihood, and we look at all these numbers. 6 of the 8 numbers are in the interquartile range. Only 2 are outside of it. It's a great way to show central tendency and show that the variability, there's a lot of people in that central group and not many outside of it. Kind of a way to show a bell curve on a line graph. Using the given data, put them in order. Remember, you can pause and try it on your own, then see what we came up with. Something fun maybe to do. Well, not fun, but worthwhile. All right? We do that. Now we look. 2 and 4 and 6 and 8. So we've got our median. Since it was an even number, we look at both of them. We add together and we divide, so we get 30 as our median. Then, we got to look at the first half. That includes these. All right? The first half median, we got to look at these two numbers, and we get 25 by adding together and dividing by 2. That's what we do. Then we got to look at the second half. Right here would be our median for the second half. 32, we add them together and divide by 2. First quartile is this, median is that, second quartile. Then we have our lowest and our highest, okay? They'll show you the same thing, but with pretty boxes. Least value and greatest value. First quartile, median of the first quartile. All right. Oh, sorry. Second quartile. Oh, second quartile, median of the second quartile. Overall median, focusing on these two, is 30. Now we got to put them on a number line. Let's do this here deal. Least, greatest. First quartile, second quartile. Median. All right, then draw the box and the whiskers. Second quartile connected to the first quartile, median in the middle. 6 of our 8 numbers fell in this range from 25 to 32. The 35 and the 23 were outside that, only 2 of them. Great way to show that central tendency. All right, interquartile range. I mentioned it before. Now they tell you what it is. The interquartile range of a data set is the difference between the third quartile and the first quartile. So let's simplify this. First quartile, second quartile. Subtract them, 32, 26. The difference is 6. Oh, the difference between these. It's what that box covers. That's the interquartile range. Less than quartile minus, greater than quartile plus. We could look at all that, or we could realize it's what the box covers. So use the interquartile range to identify any outliers. So we've got all these numbers. We're going to put them in order. Okay? When we put them in order, 2, 4, 6, and 8. Oh my gracious, why don't they give us an odd number? So we look at our median, 77. We look at our first half, which is our first quarter. We find that median there. So that would be, all right, 73.5. Okay. All right. We look at our second quartile, or our second half. We find the median there, it's 79. Okay. Then we find our least. We find our greatest. Test scores. I must not have taught this stuff very well. Okay. They identify the two halves. All right. Then they find the medians. Quartile 1, 73.5. Quartile 2, 79. All right. There's an interquartile range. So to get from here to here, there's 5.5 in between. Subtracting them shows us the difference between them. All right. Determine whether there is an outlier less than the first quartile. So this is where we use quartile 1 minus 1.5 times interquartile range. Okay. 8.25, we subtract that, 65. So our 65.25, 65 is less than that. So it is an outlier because it's too much different. 1.5 is the number they give you. 5.5 is what we saw the interquartile range being, the distance between them. If you multiply 1.5 by that interquartile range, you get a number. You subtract that number. 65.5 is the lowest without being an outlier. We have 65. It is an outlier. Now we're going to do it for the upper one. For the outlier. 1.5. So we add it because if with the upper one you're adding, you're getting bigger. 1.5 times interquartile range. Okay, that was 5.5. So we're adding 8.25. Notice the number's the same. For one you subtract, for one you add. Lower one you subtract, higher one you add. So 79 plus this number, 87.25. So 87.25, if there's anything bigger than that, there's an outlier there. We look, 82 is our biggest number. There's no outlier on the top side. Okay, let's do it again. Remember, you can practice it if you want. We order them out. All right, let's line them up. 2 and 4 and 6 and 7. Oh, 2, 4, 6. They gave us an even one. So now, 27. Oh, we look at 25. 25. 31. Let's make sure I did that right. Just see their reasoning. All right. There we are. Those are our two parts that we're looking at. 25 is one. 31 is the other. All right. So the interquartile range, the distance between the first quartile and the third quartile, or second quartile, that's 6. That's the number we're going to put in for the IQR, interquartile range. All right. Let's see if there's one on this side. So we put 1.5 times 6. 1.5 times 6 is 9. So we subtract 9 from 25, we get 16. If there's anything lower than 16, it's an outlier. Mr. 12, you're an outlier. Now, if you remember this 9, we don't have to do all the rigmarole again, but watch, they will. All right. Interquartile range times 1.5, or times, it should be 6. All right, and you will get 9. So this number is messed up. It should be 6. Okay? 31.9, 40. No number bigger than 40, so there is no outlier. All right? 12 is an outlier. Now, age of the first 10 presidents. So we look at this. 51 was the youngest, 68 was the oldest, 57 to 61, those were the interquartile ranges. That means most of the presidents fell in here and only a few fell outside there. Age of the last 10 presidents. 43 was the youngest, 69 was the other one. Remember, this book is a bit old, so we probably do not include Mr. President Barack Obama, who was one of the youngest presidents we've ever had. I think the youngest president. All right? So when we do this, between 52 and 62 is the average, but we had one that was 69, we had one that was 43. These plots compare the ages of the first 10 presidents and the ages of the last 10 through George W. Bush when they took office. All right? When we look at that, you can see the age range has increased, but that general age range has got younger and increased as well. All right? So, what does that tell you? 57 is the first quartile and the median. All right. Compare the medians and the range. All right. The ranges got much bigger. The medians got a little bit younger. Okay. The median for the first 10 president is slightly greater. The range for the last 10 president is greater. All right. That's how you can compare them. Compare the interquartile ranges. The interquartile ranges is greater for the last 10 presidents. There's a wider range than for the first 10. Okay, Oakland and Tampa Bay. These compare the scores per quarter at the Super Bowl. That would be 37. The data in the T column is the left out because it is a total of all the quarters. All right, so we didn't count this. That was the final score. Ugly game to watch, if I remember, because they scored like 27 points on, 28 points on turnovers. All right. Oakland, it's scoring between 1.5 and 9 in those first 3 quarters and 12 by the end. All right. So we have their scoring. We have the scoring of the Tampa Bay Bucks. All right. And we can compare them now. Compare the medians and the ranges. So the median or the middle score, the average score was probably at 4 or 5 for Oakland, and Tampa Bay's median score was much, much greater. So their score per quarter was much, much greater. Compare the interquartile ranges. The interquartile range is slightly greater for Oakland. They go from 1.5 to 9, where they go from 8.5 to 15 or 16. All right? We have those comparisons to make. Quartile ranges are a little bit confusing. I expect calls, so don't feel bad about calling.